Hello everyone, welcome back to my YouTube channel. Myself Nagendra. I'm from SCC Bangalore. Today's my subject is discrete mathematical structures and today's my topic is cyclic groups. In this presentation we are going to know about the cyclic groups. Unveiling the mathematical circle, explore the cyclic groups an essential concept in discrete mathematics. This presentation unpacks the structures, properties and the applications. The first one is defining the cyclic groups. Generation and the order. In the generation, a cyclic group is generated by a single element. Second one, order is a number of elements in the group or generated subgroup. Third one is the notation, usually noted G, to include the generation by element G. This is all about the defining the cyclic groups, about the generation and order and the notation. Key properties of cyclic groups. Subgroups and the homomorphisms. First one is the subgroups and second one is the homomorphisms. First one you are going to know the every subgroup of a cyclic group is cyclic and uniquely determined by an order. And the homomorphisms is about the structure preserving maps between the cyclic groups related via generators. These are the key properties of cyclic groups. And next one is about the cyclic group of integers modulo, and here we are going to know about the definition, group operation, and the order. The Zn consists of integers modern under the addition. The group operation is about the addition modulo and wraps the values cyclically. And that is the order. The group's order is exactly n. This is about a cyclic group of integers modulo n. And next one is about generators of Zn, finding the primitive roots. First one is the primitive root, second one is the existence, and third one is the finding the generators. In first primitive root, a generator of the whole group of Zn, and the existence is primarily for prime modulus n and generators exist. And so third one is the finding the generators. Check orders of elements to identify the generators and in the generator of the whole group of n and the primitively for prime modulus n generators exist and the check orders of elements to identify the generators. This is all about the generators of the Zn and finding the primitive roots and the examples of the cyclic groups in action. Rotationally symmetry, and the first one is the rotational symmetry and second one is the order. In first rotation symmetry, rotations of polygons from cyclic groups under the composition. In order, number of rotations equally polygon vertices and the count. The example of cyclic groups in action, that's the rotational symmetry. In order, number of rotations equally polygon vertices counts and rotational symmetry, rotations of polygons from cyclic group under the composition. These are the examples of cyclic groups in action. And third one, the fundamental theorem of the cyclic groups are the structure and the decomposition. The statement is every subgroup of a cyclic group corresponds to a divisor of the order. The second one is the uniqueness and third one is the decomposition. Exactly one subgroup per divisor exists and the decomposition is cyclic groups decomposed into simple cyclic substructures. This is all about the fundamental theorem of the cyclic groups and the structure and the decomposition statement, uniqueness and the decomposition. And the isomorphism and the automorphism in cyclic groups. First one is the isomorphism and the automorphism. First, the cyclic groups of the same order are also isomorphic, and the automorphisms is the structure preserving maps from a group to itself, and its corresponding to units in a modular arithmetic and form a group themselves. This is all about the automorphism, and the cyclic groups of the same order are isomorphic. These are the two main groups in the cyclic groups. Applications in cryptography and the Diffie-Hellman's key exchange. Here are basically three steps. First step is of the public parameters, a large cyclic group and a generator. Second one is the private keys, random exponents chosen secretly by each party. Third one is the shared secret, derived via exponential in the cyclic group. These are the applications in the cryptography and a Diffie-Hellman key exchange. In the private key, random exponents chosen secretly by each party and the derived via exponential in the cyclic group and public parameters a large cyclic group and the generator. These are the main three cryptography applications in the cryptography. And next slide we are going to know about the conclusion, is the significance and the further exploration of the cyclic groups. In this conclusion there are the 3 points. First is the core insight. applications, and the next steps. In the cyclic groups reveal the fundamental algebraic patterns. Let's mean the it's not the fundamental algebraic patterns, and the second is applications. It's a vital in cryptography, symmetry, and the abstract algebra. And third step is the uh, explore advanced group theory and related algebraic structures. Is the significance and the further exploration of the groups. These are the core 3 points are core insights, applications, and the next step. Cyclic groups reveal the fundamental of algebraic patterns and the applications vital in cryptography, symmetry, and abstract algebra. Next steps. Explore the advanced group theory and the related algebraic structures. And this is about the conclusion about the cyclic groups.